Good afternoon. My name is Charlie Baum, and we're going to begin our topic next on oligopoly. An oligopoly is a type of market structure that has a few large firms. This is different than in perfect competition and monopolistic competition. In those two types of market structures, there were many firms, and there were so many that no one individual firm had a particularly large effect on the profits of another firm. But in an oligopoly, the firms are relatively large and their actions have a noticeable effect on the actions of other firms in the oligopoly. As a result of this interdependence between firms, we're going to use a method to study oligopolies called game theory. Game theory, more formally, is the study of how people make decisions in situations in which attaining their goals depends on their interactions with others. In the context of economics, game theory is the study of decisions of firms in industries where the profits of a firm depend on the interactions of that firm with other firms. So we want to develop an understanding of game theory in order to analyze oligopolies. In game theory, we're going to have rules and strategies and payoffs. For example, in an economic content, a rule might be a firm's production function, or it might be the demand that the firms face in the market. A strategy might be a firm's decision, like how much to produce. And the payoffs in economics will be profits. They'll be financial payoffs. So let's look at an example. In order to examine oligopolies using game theory, we're going to be using sometimes payoff matrices. A payoff matrix is going to be a box that looks like this one. In this example, there's two firms. There's Sony and Microsoft. Microsoft picks the column. In this example, Microsoft decides whether to produce Microsoft decides whether to charge a price of $499 or $399. That's the equivalent of picking a column, and Sony decides whether to charge a price of $499 or $399, and that's equivalent to picking the row. Once Sony picks a row and Microsoft picks a column, this will indicate which of the four boxes we're in. Inside the boxes are numbers, and the numbers represent the payoffs or the profits for the firms. For example, if Sony picks a price of $499 and Microsoft picks a price of $499, then we'll be in the upper left-hand box. Sony's profits will be $10 million in blue, and Microsoft's profits will be $10 million in red. We determine profits after Sony picks a row and Microsoft picks a column. This is to say, we determine profits after Sony picks a price and Microsoft picks a price. This is an industry with two firms, so it's a particular type of oligopoly called a duopoly. We want to examine whether Sony has a dominant strategy. A dominant strategy is a strategy that works best regardless of what the other player or firm is doing. In this example, let's assume for a moment that Microsoft picks the first column, that is, a price of $499. Sony would compare profits of $10 million to profits of $15 million, and it would see that profits of $15 million are larger. So Sony would want to pick a price of $399 if Microsoft picks the first column. Microsoft might, however, pick the second column, and if Microsoft picks the second column, then Sony would compare profits of $5 million to profits of $7.5 million. Sony would see that profits of $7.5 million are larger, and so Sony would want to pick a price of $399. This shows us that even though Sony doesn't know which column Microsoft is going to pick, Sony is best picking a price of $399 regardless of what Microsoft does. We would say that picking a price of $399 is Sony's dominant strategy because it results in higher profits for Sony regardless of what Microsoft does. Keep in mind in these examples that Sony and Microsoft must move at the same time. They must both pick a price, their price, before knowing what the other firm is going to charge. Now let's see whether Microsoft has a dominant strategy. Microsoft does not know whether Sony is going to pick the first row or the second row. Assume for a moment that Sony picks the first row, which corresponds to a price of $499. Microsoft would compare profits of $10 million with profits of $5 million, and it would determine that profits of $10 million are larger. I'm sorry, let me back up. Let's suppose that Sony picks the first row, which corresponds to a price of $499. Microsoft would compare profits in the first column of $10 million and profits in the second column of $15 million. Profits in the second column are higher, so Microsoft would want to pick the second column, which corresponds to a price of $399. It's possible, however, that Sony will pick the second row, which corresponds to a price of $399. In this case, Microsoft would rather pick a price of $399 than a price of $499 because profits of 7.5 million are greater than profits of 5 million. Microsoft and Sony must pick their prices at the same time. This means Microsoft doesn't know which price Sony's going to charge when Microsoft has to pick a price. But Microsoft actually doesn't need to know which price Sony is going to charge because Microsoft is better off picking the low price regardless of what Sony does. Since Microsoft's dominant strategy is the second column, which is a price of $399, and Sony's dominant strategy is the second row, which is a price of $399, this tells us that if both firms follow their dominant strategies, we will be in the lower right-hand box. A Nash equilibrium is a situation in which both firms choose their dominant strategy. And this is the best strategy given the strategies chosen by the other firms. Another way of saying this is a Nash equilibrium is an outcome where neither firm can do better by changing their behavior. In this case, the Nash equilibrium is clear because both firms have a dominant strategy. It's possible that a firm might not have a dominant strategy, but you can still have a Nash equilibrium in a game. Notice this lower right-hand box is a Nash equilibrium. If Sony picks the other row, its profits will go down. If Microsoft picks the other column, its profits will go down. So neither firm has an incentive to change their behavior. You'll notice at any of the other boxes, one of the two firms could increase their profits by picking the other outcome. If we were at the upper left-hand box, then Microsoft could increase profits by picking the other column, and actually Sony could increase profits by picking the other row. So that's not a Nash equilibrium. In the lower left-hand box, it is Microsoft that could raise its profits by picking the other column, so that's not a Nash equilibrium. In the upper right-hand box, it's Sony that could raise their profits by picking the other row, so that's not a Nash equilibrium. The Nash equilibrium is in the lower right-hand corner. You'll notice that the lower right-hand corner has both firms charging a relatively low price, and it corresponds to profits for each firm of 7.5 million. That's the Nash equilibrium, and yet both firms could be made better off if they were to choose a higher price of $499. With a price of $499, both firms earn 10 million in profits. So the Nash equilibrium is not the outcome with the highest combined profits. This may raise the question of why don't the firms collude? That means form an agreement not to compete with low prices, instead to charge the same higher price in this example in order to increase profits. Collusion is against the law in the United States, but it's tempting to collude because firms can raise their profits by agreeing to charge higher prices. This is difficult to achieve in the real world, however, because in this upper left-hand box, both firms have an incentive to cheat. Sony has an incentive to charge a lower price in order to increase its profits, and at the same time, Microsoft has an incentive to charge a lower price as well in order to increase its profits from 10 million to 15 million. This is an example of a prisoner's dilemma. This is a particular kind of game in game theory in which the dominant strategies result in non-cooperation, and that leaves everyone worse off. The players could be made better off if they were to cooperate, but the cooperative outcome is not the result of dominant strategies. Let's look at one more example. This is going to be an example that considers a cartel. A cartel is a group of firms that come together in order to collude. They collude in order to raise price, to raise profits. These firms in the cartel collude by restricting output. Cartels and collusion are illegal in the United States, but they're not illegal in some countries. And an example in the world of a well-known cartel is OPEC. That is the Organization of Petroleum Exporting Countries. These countries that produce oil restricted output in order to raise prices and profits during the 1970s and 80s successfully, and they've continued to try and do it, but without as much success. Let's look at one more example of a payoff matrix with two oil-producing countries. The first one is Saudi Arabia, which is a very large country, and its actions dramatically affect profits. And the other one is Nigeria. It's a relatively small country, and its actions don't have as much effect on profits. Saudi Arabia's dominant strategy is to produce a low level of output because that results in higher profits regardless of which column Nigeria picks. If Nigeria picks the first column, Saudi Arabia is better in the top row. If Nigeria picks the second column, Saudi Arabia is better off in the top row. So Saudi Arabia's dominant strategy is to pick the top row, which corresponds to low output. Nigeria has a dominant strategy, and their dominant strategy is to pick the second column. If Saudi Arabia picks the first row, Nigeria's profits are higher in the second column. If Saudi Arabia picks the second row, Nigeria's profits are higher in the second column. So Nigeria's dominant strategy is the second column, which is high output. Saudi Arabia's dominant strategy is the first row, which is low output. And so the Nash equilibrium is for the firms to be in the upper right-hand box. You'll notice, however, that the upper right-hand box is not where joint profits are maximized, and this is because Nigeria has an incentive to cheat, not abide by a cartel agreement with low output, and instead produce a high level of output and in the process raise its profits from 10 million to 15 million. This is a good illustration of why the cooperative outcome, where profits are maximized, is difficult to achieve.